Hello everyone and welcome. My name is Kyle Grantham and I'm thrilled you tuned into River Geeks. Today we will be covering how to develop a 2D floodway in HEC RAS 2D using the 2D floodway encroachment tool that was released in HEC RAS version 6.4. This is a two-part series. As for the first part of this series, we'll be covering how to develop a floodway in HEC RAS 2D. The second part of this series will cover how to post-process the HEC RAS 2D floodway results. If you haven't already, please like, subscribe, and don't forget to hit the bell notifications so you don't miss out on any future content. So today I'm going to provide a brief overview of floodways and illustrate how floodway encroachments are integrated within the most recent edition of HEC RAS, which is HEC RAS 6.41. And so the FEMA definition of a regulatory floodway means the channel of a river or other watercourse and the adjacent land areas that must be reserved in order to discharge the base flood without cumulatively increasing the water surface elevation more than a designated height. And for our scenario, that height is 1 foot. So what we're going to do, we're going to use floodway encroachments to develop this floodway, which in the real world are activities or construction within the floodway, including fill, new construction, substantial improvements, and other development. So how this is integrated into HEC RAS is when you set those encroachments, HEC RAS will duplicate the terrain and it sets the elevation of this of this encroachment based off what you give it, which is, for our scenario, we're giving it 1 foot, so it's going to be 1 foot above the base water surface elevation. And so the goal is to have a surcharge of 0 to 1 foot. So that's the goal. So if you see a surcharge greater than 1 foot, then it will be plotted outside of this encroachment region. So what we're going to do is we're going to work our way from downstream to upstream, and as you work your way from downstream to upstream, adjusting your encroachments, this will once you make adjustments to that encroachment region, you will eliminate the surcharge issues. Hey everyone, so today we're going to be working on developing a 2D floodway within HEC RAS. I'm going to be using, to do some editing, I'm going to use QGIS. So we're going to start with, so I already have, this is a model already set up. I have the 100-year plan file. So as you can see, I have the 100-year plan file. And so you will, just something to remember is that the geometry will be the same. The flow data will be the same, and then for your plan file, you're going to just duplicate this plan file for the floodway run. And so what I'm going to do is I'm going to go ahead and save this as 100-year floodway. Your floodway. Okay. And so I've already run the 100-year. So we're going to open up RASMAPPER. And so what we're going to do is we're gonna start with the unit discharge. So what we're gonna do is add new map. We're gonna go to depth times velocity, make sure this is maximum, and we're gonna add to map. So, and then we're gonna compute it. So this is what we'll start with. And so we'll go to plans. You'll open up plans, go to your encroachment regions, and you're going to edit that. And what we want to do is generate floodway encroachment polygons. And we're going to do this from the map results. And so we're going to use that 100 year. And for the map layer, we're going to do the unit discharge, the depth times velocity. For this, resample cell size, we'll keep that blank. And also, if you want to read more about this, this is on the HEC RAS 2D guidance. For this contour value, we'll use 2. Filter tolerance, we'll use 5. I'll use 20 for simplified tolerance. And this is what is included in the manual. So there you have it. Now we will need to set up that floodway run. So what we're going to do is you're going to go to options, and then you're going to go to unsteady encroachments. And then we're going to set that target rise for 1. The fill slope on terrain modifications, we're going to set that to 0.1. And so what we're going to do, we're just going to run that. Okay, so once our floodway model has run, this is where we're going to set up our comparison data sets. And this is what we'll use going forward. So once we start making multiple floodway model runs, we can visualize the comparison data set. So we're going to go to create calculated layer. And we're going to go to make sure this is compare water surface elevation. So it has a little preset script. So you have your water surface elevation 1 equals 100 year, which is your base run. Your water surface elevation 2, which equals your 100 year floodway run. And so we're going to modify the script a little bit. That way we're not plotting our 100 year base inundation. And so to do that, we're going to change this to if water surface elevation 2 is greater than or equal to water surface elevation 1, then output equals water surface elevation 2 minus water surface elevation 1, else output equals no data. And if call this 100 year floodway comparison. All right, so I can include this script within the description that for an example. So what I'm going to do now is once I have that together, hopefully this works, we're going to create this layer. It already, okay, we're going to overwrite that. All right. And so we're going to click on max. And so we haven't given this floodway comparison data set a symbology yet, so it doesn't have any color to it. And so what you see here is there's some gaps where it's not plotted, and that's simply because the water surface elevation of the floodway run is less than the base run. But once we start to bring that the encroachments in, it's going to push that water surface elevation up, and then we will see that data set plotted. All right, so what we're going to do now is we're going to go to Image Display Properties, and we're going to edit. And so from here, we're going to set that max as 1.04 and then negative 0.04. And then so I have a preset color ramp, which I can provide with this video as well. And so we'll click on that, River Geeks Floodway. And so for pink, we have negative 0.04, zeros, this blue, 0.25 is a lighter blue, and then 0.9, which is kind of what we're trying to achieve. We have that as green. 1 is green, and then anything above 1.04 is red. So this is when we're going to bring in our encroachment region into QGIS so we can apply that buffer, and it's going to be multiple iterations of just adjusting this floodway, and we're going to do that in QGIS. And simply because RASMAPPER, you can't apply buffer, and also by reshaping the floodway, it's a lot easier within QGIS. And I'm hoping that maybe this will be included in one of the future updates within RASMAPPER. So what we're going to do is we're going to take that encroachment region, that initial encroachment region we had, we're going to export that as a shapefile. And so I have a floodway folder within the RAS model, and we're going to call that floodway encroachment. And so once that's exported, then we'll bring that into QGIS to modify this polygon. So now that we're in QGIS, we're going to bring in this floodway encroachment shapefile. So I'm going to drag that shapefile over there, and then from here we're going to start off by buffering this. And we're going to go with 50 feet. We're just going to bring it in 50 feet. So you can just go to your processing toolbox and type in buffer. We're going to put 50 feet. And then we're going to save this to a file, and we're going to save that as Floodway Encroachment 2. So what we're going to do here, we're going to bring this into RASMAPPER. So what we're going to do here is we're going to edit this encroachment region, and you'll delete out the existing encroachment region. So we'll come here to the encroachment region, and we're going to import from shapefile. We're going to select that floodway encroachment 2 shapefile. We're going to import that. So now that we have our buffered floodway encroachments, now we're good to go with making a model run. So from here, we're going to make sure this is configured. So we're going to go to unsteady encroachments. We have our target rise is 1, and then our fill slope on terrain is 0.001. Save that and then run this. Okay, so after the model run, you can see it's the symbology is updated, and you can see that we have that very high surcharge upstream of this crossing, and that's simply just because when I did that buffer, it just pinched right around this structure. It pinched, caused a pinch point and just caused a surcharge. I'm not too worried about this right now, since I'm working my way upstream. We're gonna work our way upstream by squeezing this floodway in. So don't get too caught up. If you're seeing issues upstream, you need to work your way from downstream to upstream by modifying this encroachment region. So what we're going to do now is we're going to go ahead and apply another buffer to this encroachment. So we're going to buffer this by, we're going to start out with something significant. We started out with 50 feet initially. Now we're just going to buffer the initial run. Let's just say 100 feet. So I'm going to save that as 3. And then we're going to go to RASMAPPER, edit encroachment region, delete that out. Import that from Shapefile. Okay. And so now we're going to run this again. So we're going to make sure we have 1 fill slope, 0.01, and then we're going to run this again. Okay, so you can see the results from our latest run, and it looks like it's just blew up upstream of this crossing. I'm not too worried about that, and I will fix that here in this next model run. I'm just going to eliminate that pinch point. So, but we're just going to focus on this downstream extents. I'm going to bring export this extents as a JPEG, so I can kind of see where the increases are and decreases in surcharge. So you want to make sure your window is covering the extents of your inundation. And so you're going to go here and export current image to a JPEG. And we're just going to call that Floodway 1. And so within QGIS, we're going to drop that extents in so we can kind of see where we need to bring that encroachment in. And so from here, this is where it gets very iterative. And so what you're going to do here is we're just going to edit this encroachment. We're going to reshape. So we're going to select this, and then we're going to reshape this encroachment. So I'm just going to simply just go through here. and you can do a little bit of at a time. I'm going to do the same for this downstream side. Okay. So now this is where it turns into very, very iterative process. And so we're going to go to this encroachment region, delete it out. And then we're just going to import that floodway encroachment 3. We'll save that. And then we're going to make sure this is 1.01. And we're going to run this. And as you can see, based off the last results, I brought this in a little bit too much. So what we'll need to do is modify this where I'm not bringing in that encroachment in so much. So what we're going to do is we're going to edit this floodway encroachment 3. I'm going to bring this in a little bit. And we're going to modify this as well. Okay, so now that we've modified this encroachment, now we're going to go back to RASMAPPER, go through the same process, edit, delete, import from shapefile, Floodway 3. So we're going to import that, save. Now we're going to rerun this again. So we're going to rerun this. So something I failed to mention is to export in your existing 100-year inundation. And so for that, I've already done this, but you'll just go to the map parameters and you're going to export the inundation boundary. And so you'll just compute that. And once you do that, so this is when we'll bring this into QGIS. So let's go to QGIS, and we're going to import the inundation boundary. So we'll go to that 100-year folder where the output for the inundation boundary is, and we're going to bring that in, and let's make sure this is at the very top. And then we're going to make this hollow with the outline of red. And that way you can see kind of where the existing 100-year water surface boundary is, and you can use that as a guide for when you're shaping up these encroachments. So in QGIS, when I'm adjusting my floodway encroachments, the layers I want are we want the existing base floodplain inundation boundary or floodway encroachments, and then we want the terrain, and then we want that JPEG so we can see kind of where the surcharges are. And so we can use we can use the terrain to kind of see where the channel is, and just see how the topography lays out. So I think y'all get the point now. It's a lot of back and forth iterative process of adjusting this encroachment. And so what I'm going to do, instead of videoing me go back and forth with this process, I'm just going to show you kind of what the finished product will look like. So after multiple iterations, we finally have achieved developing this floodway with no surcharge issues. So I'll turn off this terrain in the encroachment region. You can see it's a bluish green. So we're getting that range of between 0 and 1 foot. Try to get as close as we can to a foot. And so I went through this, and now we are ready to post-process. And so that will be something we're going to tackle for the second part of this series. So thank you guys for tuning in, and I hope you tune in for the next part of the series where we'll actually start cleaning up this floodway and get it ready for the final product. Thanks again.